Assalamualaikum and very good day to all the participants of IPCME2021. I'm Abaqus from Region M, and today I want to share with you our findings and research that we have conducted back in UKM and performed by our student, which is Amir Hussain, under this topic, which is the effect of graphene addition on the young modulus and tensile strength of Kenaf Fibre composites. Okay, so you might wonder why Kenaf and how it actually contributes in our daily life or our application, how it's applied, and how it's very close to us. Actually, this Kenaf was not a very new materials or not a very new invention. In fact, in Malaysia, we are using this Kenaf like back to 10, 20 years, and it's go very fast. This Kenaf is has been used like for NCID. They're using it, use it in terms of furniture, and in fact they are using it in many other types of products, uh, bag, t-shirts. This can be anything. And in our case, in our study, we get to know that this enough was actually very beneficial in terms of automotive parts. Okay, when we mention on the automotive parts, you might wonder what types of parts that can cover up this Kenaf composite, for example, since as we all know that composite consists of two types of materials, and how good is Kenaf, since if we talk about automotive part, it should have a very excellent performance in terms of mechanical strength, etc. So actually, there are several types of targeted parts in automotive. For example, we are targeted on the battery tray, the what we call dashboard, for example, in order to replace these current materials that we will use for types of natural composite. Okay, because this is not a very new materials, and in fact, in Malaysia, we got our Kenaf supply from the Abaqus Kenaf and Tobacco Malaysia, which you can find Kenaf has the plants all around Malaysia. For example, in Perlis, in Kelantan. Okay, and in our case, we got it from Kelantan. So as you might see in here, it is not something very new. And in fact, our research group have succeeded in fabricating a battery tray by using this Kenaf, because you know Kenaf have very types, such many types. For example, in terms of powder form, it can be a long enough, and it can be a short enough. And usually enough, you need to undergo specific uh, surface treatment in order you to combine it in with polymer, for example, because the structure, the Kenaf surface was very hydrophobic. So we need to undergo some surface treatment in order to reduce the hydrophobic uh, that happen, and then in order it to become can absorb more and or to combine more with polymer. But we need to control in terms on how it water absorption itself, because we know when we apply it into automotive application, for example, as a battery tray, we don't want it to absorb so many water uh, that it might result in reduce its performance or degrade it, what we call deteriorate its mechanical strength or tensile strength to be specific. Okay, that's the case. And then this is types of Kenaf that I mentioned just now, and details on which it was something not very new. It was already been done all around the world, but yet what makes our research very novel or very can contribute and can chip in within this what we call uh, plenty of research that have been performed. How can we contribute it? So in our case, we did identify that one method in a way to replace the what we call technical or conventional surface treatment process. For example, usually we need to undergo for alkaline surface treatment, but in our case we just need to comb it. Okay, we just comb the canal. It's basically it was a very what we call, you can comb long enough and then chop it into to become it into powder form. It depends on your own creativity, but in our research we are more focusing on the how we intentionally prepare the canal itself, okay, and how you can contribute on that. Because in our case we found out that when we comb the canal, the long canal, the strength itself will be much better compared to the conventional materials that being available into the market. That was already proven, and in fact our research group are now filing for patent for these types of techniques. Okay, then if you go through, there are some simulation and optimization in the forming process. This is something to talk about the manufacturing process, because we know that Kenaf has many types. We have long shots, in fact we have powder, so different types of materials which consist of different types of manufacturing process. So in our case, we have like two types of method we are implemented. One is for long canal, we are using this forming process, and for the powder types of canal, which is a shorter canal fiber, we usually fabricate it by using injection molding process. So as you might seen before, that our battery tray that we succeed in what we call prepare, we actually fabricate it by using injection molding process, which is it was using the very small size of canal fiber. Okay, then in comparison, because we know the there's there's so much improvement that we can make or and alter when we do some simulation. So we will need to, that's why we are conducting some simulation by using burn forms, and then some are using this mold. So because the idea was how, in order how we can detect any defect that occurred, because we can maximize and minimize, and in fact we can alter the parameter by based on this simulation process. Okay, that's how we are conducting in this all this while. Okay, so in this study, I'm sorry these slides might have some points in Malay, but I hope it did not disturb much. Okay, so our canal was, we are using this very short canal, and we combine it with graphene. Okay, the reason why we combine it with graphene is for the idea to improve the mechanical strength, the tensile performance, for example, the tensile strength performance, because the addition of the graphene, however, can increase on dose, but there are several up until several percentage only, because if we put so much graphene on it, then it will somehow deteriorate, and it cause the tensile strength to drop. Okay, that's the case. So that is the one that we try to alter and study on those. In fact, this graphene itself can be easily agglomerate, and how the graphene itself want to we combine the filler, the primary and the secondary filler itself. That's what we intently study during this for this project. So basically, this is how we perform on those experimental works. Okay, then there are some. Here is the right part was actually the samples by using this short canal. Okay, so as you can see that it was actually by adding this graphene as a secondary filler, you might add like CNT or carbon black. It was actually the purpose was also other than increase the mechanical performance, it was actually in order to improve the aesthetic value. We want to see the color turn to black compared to the what we call an actual the basic, just a base of polymer and Kenaf itself, which is a very plain and brown color. Okay, and then we do have some studies involving orientation, and by using this long Kenaf, as you can view in here. So we conduct some different types of testing by using different types of materials to see how it reacts or how it um, actually becomes what's the output. And then in fact we have compared it by using the available materials, which is this one from Toyota cars. We get the dashboard and then we cut it into appropriate ASTM standard, and then we do some testing in order to see how actually ours compared to the conventional products in today's market. So as you can view in here, that as the addition of graphene increase up to 5%, the tensile strength tend to drop, start from 1%, which is 23 megapascal, drop until 22.8, which is a very minimum drop, but still there's a drop in here. Okay, compared to the addition of 1% or 1% of graphene. So this was basically, if you go back to the preparation theory, there are the exact amount of secondary failure can be at, because after that, when the preparation theory, the value reach its maximum value, then the results, it will result on a play two compared to based on the addition of the material, the secondary filler itself. So this was basically the same things, in which we can assume that 3 and 5% of graphene here, which won't give any effect if, for example, if we add 6 or 7% of graphene, it won't give any much changes. The result would be remaining the same, which is 22.8 plus minus only. Okay, so other than that, after we got collecting all the data, we get the we input it into the simulation by using this Abaqus, and then we get to know that Kenaf addition of Kenaf until 5% would experience much more what we call stress compared to the 1% graphene addition. Okay, then this is the comparison between the actual experimental data with the that been performed by previous researcher compared to our simulated data. So as you might see in here, that addition of 3 and 5% of graphene, uh, the 3% was it's reached the maximum, which is 21.3. That's why it's kind of similar to our simulated data, which is 22.8. So here we get to know that the maximum graphene content was actually 3%. It's not 5%. Since it did not give a much different, and in fact in actual application it's reduced like 10 to 20% compared to the 3% percentage of the graphene. Okay, the reason here might due to this agglomeration, and in fact there are when there are more addition of this what we call graphene, then it would cause an not in anisotrophic phenomena, which unfortunately cause much more cracks during the process. Okay, so we also do some comparison by using this commercial product, and you might see in here that this um, ours kind of polypropylene have uh, much much more better compared to the commercial products in which in terms of this contact angles and then this water absorption in here. Then there's my view to this fiber that was aligned properly into one direction, which is zero angle, compared to the um, it was randomly oriented. Okay, this was when we are using the long fiber. Okay, this is if we compare it by using the long fiber, because we did not perform any tests on or comparison yet with short fibers, because it will be conducted later on whenever students are available to enter the lab later on. Okay, so it is obviously that ours have much more much better performance as compared to the actual product in today's market. As you might see in here, the tensile strength was like 90 megapascal, while this product was only 30. So obviously, this Kenaf fiber was highly potential to be used in available and to be applied in actual automotive parts. Okay, so basically that's thank you, and for those students and academicians who want to submit their journals under journals of engineering or journal kejuruteraan UKM, you might want to access this journal kejuruteraan, which is currently site under STWOS. Okay, so I think that's all. Thank you.